Welcome, ladies and gentlemen, to today's session for the University of Cape Coast students and youth mappers. Today, we are going to do a follow-up training of the session we had in June this year, 2025. Welcome. Digital Africa is powered by partnerships and working for all the countries to provide analysis-ready data. This data is very crucial to support countries in addressing their national development agendas, as well as supporting sustainable development goals and the Greater African Union Agenda 2063. Digital Africa is powered by Amazon Web Services and uses Open Data Cube technology. Digital Africa is working with partners across the continent, from East Africa, South Africa, North Africa, West Africa, uh, working closely with the implementing partners, Regional Center for Mapping in Nairobi, Kenya. We have Sahel and Sahel Observatory in Tunisia, Center de Suivi Écologique in Senegal. Also, we have agreements in Niger, Afrigist in Nigeria, and other partners. Digital Africa has been able to develop continental services, which are very key to support the development needs. Digital Africa is providing the data, analysis ready data. It's the data from the space agencies. We have Landsat and Sentinel-1, 2, and 3 from the European Space Agency. The data analysis ready data is data now that you can actually use to get more information. The Committee of Earth Observation has sat and given these guidelines metadata. Digital Africa is one of the largest open data cube and providing a continental scale satellite archive for Africa. These continental services have been co-developed with partners across the continent, and the program also has capacity building program online courses, as well as available to provide our other sessions face-to-face or online. Access to the platform is through various interfaces. We have the map, the sandbox, and the explorer. The continent is faced by different challenges from agriculture, food security, water resource, land degradation, urbanization, coastal erosion, name it. Digital Africa provides the insights, looking at the continental services. We have the water observation from space, the water bodies, coastline monitoring, cropland, and geomap cloud-free mosaics. Water observation from space was the first service from Geo Africa. This was the year 2020, and it provides insights into water availability from space. This one now goes back to 1985, providing over 35 years of data to actually more. This is actually helping countries to make more assessments on the water management. Coastline service has been developed by Digital Africa, and there's been a lot of code development as well as validation. This data provides insights into the hotspots, rates of change, the changes of our shorelines, and enables coastal management. This data ranges from the year 2000 to 2024, and it covers over 24 years. Very useful to inform our coastal management plans. We have the water body service also as a build-up of the water observation from space, and this one shows the levels of individual water bodies, which are more than 700,000 across the continent. It's providing insights into wetlands which might have dried and some which have emerged thereafter. This covers from 1985. This is very useful, almost covering over 40 years. This is a very useful insight. Access to the Digital Africa platform is free, and we have the various interfaces from the Digital Africa map, the sandbox, and also possible through API, so the web map services, and also we have our free online platform. Access to the platform, as you can see from our website, we have the section on the platform. You get more insights into those map, sandbox, the notebook repository, Africa Geoportal, the metadata explorer, as well as the other standards on the web map services. the continental services are available for free as well, free access. You can get more information of the coastline, cropland, fractional cover, geomud, vegetation anomalies, water bodies, and water position from space. The analysis data is available of the Landsat and Sentinel. Here also we have access to the Africa Job Portal. We partner through Esri, and here we can get more information in terms of how to be empowered and also plugging into other services via Esri, inspiring communities indeed. Please allow me to show this short demo to access the platform. On the website, you can be able to see how to access the various nodes, platforms, services, as well as the analysis data, including more information. I wish to take you to the digital Africa map, and here we can be able to see how to change the interface, the map, to the map, looking at countries and going to Ghana. And here we're able to explore the data sets, the continental services, the coastal, surface, water, and vegetation. We also have the external data sets, the satellite imageries, surface reflectance, Sentinel-2, available every 5 days. Please, let's go to Cape Coast, and we can load the imageries. As you can see, even on the background, the lagoon, and also our University of Cape Coast. Here we can load the data and query to our location, and also cognizant of the cloud cover, we can now actually navigate to different times. So as we load the image, you'll see the cloud cover, and we can change from week to week. And as you can see, we are able to get at least an image of the 22nd of October. And we can also be able to go to many years ago, 2017, January, and you can see the situation then. And we can also do a comparison of two images. Very key, seamlessly possible. Looking at the, on the fly analysis, looking at how our area of Cape Coast has changed over time, and also being able to get more insights. So we can compare 2 times, January to January. However, sometimes you can experience exceptional, have internet connectivity, as I was trying to do this part. Nevertheless, I'm able to load one image, one set, so that I can demonstrate the capabilities of each service. So this particular data, looking at this particular year, we can be able to see the university. We can also able to load the data and make some changes in the band combinations just on the fly, for color composite comparison, looking at our area in Cape Coast, the small lagoons. We can also change the styles. We can also add vegetation index, looking at the situation in the area. We can also do the water index as well. This is very nice, as we can explore data sets, looking at some of the lagoons, the mean water index, difference index. The possibilities are many. Even the water quality index, we can be able to see how that can really work. So there are many possibilities with the data, exploring, getting insights, looking at the resources around, looking at the growth of our cities, name it, looking at agricultural productivity, etc., etc. Please, let's look at more of the services. We have the Landsats, we have the Sentinel mosaics, data on the urban, data on the vegetation. There are very many possibilities. Looking at the continental services, we have the GeoMud Sentinel. These are cloud-free mosaics for the whole continent. Looking at the year 2024, a summary, we can be able to do comparison of the GeoMud, the fly, one 2017, the other one 2014. We can be able to see a lot over the last 7 years. Quite good comparison. is observed, especially around Cape Coast. Just looking at the areas that we could be able to look at. So this data set is available for the whole continent. For example, if your use case is anywhere else, the continent, but all the same we have these for us. We can be able to change also the bands, also false color composite. Just look at the visualization. That is what is key for today's, to explore. And also you can see the forest reserve around there, the northern part. So the possibilities are many. So looking at this also, we can be able to access the sandbox as well. Here, I wish to pause so that we can see if you've been able to activate your sandbox after the technical review, which was done earlier this year. So the first step is when you go to the sandbox is to sign up if you've not already activated your sandbox. And after you sign up, you'll see the details to add. And after that, you'll be able to have the activation step where you'll receive confirmation via email, and thereafter via your phone. Once you've activated your account, or in case you have any challenges, you can write to us at help desk, or actually I can do the follow-up as well. Once you've activated your sandbox, you can actually now log in and choose the different modes. So welcome back to the sandbox for those who have been using it and are back. And for those who have just connected, please welcome. These are the various thematic areas that the platform is able to help us from agriculture, coastal land cover, machine learning applications, looking at the weather, also radar data, SAR data, cellular imagery, looking at the Sentinel, Landsat, soil data, surface water. This is where we have a lot of applications, the water as well as the urban, name it. On the landing page, we also have the SDGs. Teach South Africa is really working closely with the different stakeholders, looking at agriculture, food security, looking at the water resources, looking at also urban goal 11, looking at climate action, also looking at in the ocean and also land cover and land. And definitely with these collaboration or partnerships, we're able to provide all these to all stakeholders and work closely with you to get more feedback. In the agricultural food security, we have different examples looking at crop health, also phenology. And the first one is just to show you in the sandbox, these are the various notebooks that we have to support agriculture food security. So in our Digital South Africa map, I wish just to show an example of a region in Upper West where is shared by the Ministry of Agriculture farm areas in Sisala. And here I wish to add the Digital South Africa crop land crop mask so that you can see the value of these data sets. So you're able to change the various backgrounds. This is the base map imagery, but on the fence, cropland is able to show the farm areas. And also, as we know, probability of cropping is possible now at crop level. You can see different colors as per the legend. Towards yellow is where we have evidence of farming activities. So this is just a good as we continue the example so that we can see the correlation of these cropland mask data and its value to support a crop type mapping as well. So we can get object level, farm level, but this is the greenness indicator. But now probability of cropping is actual data where there is probability, highest probability of cropping. And you can see more information about the data set developed in the year 2019-2020 for the agricultural ecological zones. And it's data set that you can download, you can share as well, copy, or even generate a story map. Name it, name it. So with that data set gives us an understanding of our farming area, so that when now we go to the sandbox, we can be able to see the actual example. So on the crop health, this was the area started Sisala, and these are the coordinates that are provided. And here I wish to show you the notebook and its example. So uh, the notebook is in the real world examples. We have the crop health notebook, and here I'm able to demonstrate that using Sentinel-2, we can get the vegetation index, and it's a step by step when you run and just set the coordinates of your area. This is Isala East, Ghana, and these are the data sets loaded for the NDVI Sentinel data, looking at a period of 2024. So we can digitize individual plots and see the vegetation, and also cognizant with our rain season around August, sometimes October, we can analyze and see the cropping, how it was from one year to another. So it's a critical resource that we have. So this particular example, this is where I was. So in the real world example, we digitize the plots, and these are the graph. And from the graph, we can look at adding additional points and seeing that those are similar crops based on their phylology. And we can also add other plots and see, because this most likely is an area of mixed farming. And you can add a different region. And you can see how typically this is plotted. So this also gives us some insights for an area. Similar crops will have the similar NDVI trend, but some will have different trends based on when they were planted. So it gives us quite some information over time. So looking at the area, we can actually choose to change the dates. We could say the year 2023 and run it, so that you can get quite some comparison. And as it goes, we'll be able to see the trend, and we can do this for any area of our choice, and it will just load shortly. And you can see the number of datasets added over 79 time steps. And from these, the year 2023, we could see possibly the scenario was different. The farmers were growing at different times, but no similar less than the curve we had in the year 2024. And also we have some years where the rains are delayed, or sometimes rains come on schedule. So this particular case also rain around July, August, and peaks. And also in our user guide, you can see more information about this particular notebook. This is the crop health. So this is one of the most interesting use case in agriculture food security, getting that trend and getting more information about crop productivity from space. With this one now, wish to look at forecasted vegetation. It's also very key at looking at this particular model of moving average gives us an idea of the vegetation physiology in the next 1 or 2 months for the same area. Also, we have the example of vegetation phenology. This one is very key because from the other example now, we're able to use the same extents and get more information year by year for the same region, the same area of interest. In Upper West, From this Sisala, we are able to get more information in terms of phenology. So this is just realigning us with where we are located for this particular example. So this one is based on the areas that you have in mind. We can see the data sets loaded over 129 times. And from these, we can make some assessments. This was data, for example, in the year 2019, looking at the plotting of the vegetation. And we are noticing the peaks around October harvesting. And we can look at the trend in the vegetation and the trends respectively. So we can see the start of a season, the end of a season, harvesting time, and not possibly where we have different curves could be the crops who are affected. So this is the start of the season, and the peak of the season around October, and the end of a season in December, where they actually do some replanting and plan for the other year. So this gives you the analysis. So the peak, start of a season, and the end of a season. And from this, you can also choose the different dates so that you can get more information per year analysis assessments. It's a very good assessments that we can have, and you can compare also with Sentinel-1 data, radar data. So when you compare with radar for the same data, you can see the graphs are almost similar. This is the Sentinel-1 data. We see the start of the season and the peak of the season around October. Similarly, we can also generate vegetation animations, very key, because we couple in the same area we are looking at and now getting more data sets, more information on the vegetation change. And also we can add more information on the rainfall so that we can get the trend in the vegetation. This is the vegetation animation. So you can see the trends and the anomaly. Then also we can compare with the rainfall data. And in the animation, we'll be able to see something that we can make some sense. The rain has observed and times when the rains are possibly delayed. So this is a very good way of complementing the results that we previously presented. So we also have the ASA World Serial Data in Digital Africa, and this particular example, we have in the datasets folder, ASA, the datasets, the serial data, and this one we're looking at maize. So we could look at the same region, and from that upper west, we're able to see access to the ASA World Serial Data and the various classifications. And from that, we can see temporal areas, which are crop areas. And from that, we can try to get active cropland, which is possibly the whole area, and some areas in dark green. And from that, we are trying to look for maize. We could possibly see some active crop data, but different times, planted at different seasons. Then we try to visualize the maize extent in dark green. And also getting some possible results on irrigation, which was not so much. And also trying to get information on winter crops, not so much. And also no much irrigation in the area. And finally coming up with a small summary of some active rain-fed maize. So from that also we can look at plant area mapping. It's in Sentinel-2. This one is / agriculture land cover. And we're using an example of somewhere in West Mahopupuri municipality of somewhere where there was reported fire extent incident. From these, it was recorded this particular time, and these are the extents. And from that, we are able to connect to the area and north and northeast and upper west. So when you go, we navigate to the area around north and east, we can see, be able to load the data sets, Sentinel-2, and also be able to get some results, the normalized band up area, and we can see the baseline data, then post event of the fire. We can couple with the MODIs and also examine hotspot areas. So this is the fire information for resource management, connecting the data, and to give us an indication of areas which were recorded. And from that, we can get a comparison of the baseline and the fire incident spots, and provide a map which gives you more information for decision making. This is one of the good examples, especially when we have extreme temperatures in summer. So the one before and after the fire incident. So the normalized band up ratio, so the baseline, the post-fire, and finally we have the calculation of the band up area in terms of extent, and you can export the results as a GeoTIFF. Where we have the TIFF file that you can load in your other programs for further analysis. So we also have the mountain green index, and this was an example shared by one of our colleagues at the Ministry of Agriculture. And we were looking generally generating the data sets, which was quite a process, and having data sets for certain areas. And from that, we were able to come up with an index country level. Then an example of the water resources, showing you the water extent. These are the various notebooks that we have. So the first one is to take you back to the example in the Digital Africa map, looking at the surface water. We can look at the whole country, our country, Ghana, look at the observation, the frequency of water from blue, deep blue being water, and areas from yellow to red, drought areas. So we have our very own Lake Volta, as well as some of the water bodies that you can recognize. We also have, so we can go to Lake Bosom Twi, and here we can add the water bodies service. And here we can click and get more information in terms of our individual water body, the water observation. This is the water body service. And once we load the chart, we can see from when we had water and when we had dry points. So this is different for each water body that we visit. So you can also look at small individual water bodies as well. There was one particular one, a previous example near Bongo. It's called Avea Dam. We can click on it and see the result. So this platform is really empowering us to look at uh, our water resources and also get more information from other stakeholders like youth mappers, OpenStreetMap Ghana, and other stakeholders, because citizen generated data is a key to help us complement these continental platforms. So this is the scenario, the extent of the area, and very useful for us to make critical decisions. So this particular dam has really dried. You can see where it was developed sometimes, and it has really, the water has been really variable over time. So case in point is to do some examples like Lake Bosom Tui. We have looked at it from the water observation from space, and also now looking at an example using the water index from Sentinel-2. We can be able to run this notebook in the real world examples, the extent of the area, Bosom Tui. We can be able to get more information, and from this, we're able to get the water index, and you can see the various times through the life of the water body. So this is a very useful tool for decision making. You can run it up to even 2025 to get more insights, and also coupled with more information on the ground or other sources, we can actually investigate the drought point or the flood points. Today, we are really empowered with these tools, and even coming up with some examples that we can actually explore. So from this, we can also look at the individual water bodies. So this one now gives you the actual graph from different dates to particular times through its life. So from that also we can look at the water quality service, Africa, which is currently being finalized and will be available for the whole continent. It's an example of Lake Volta, just looking at the water quality from space. The notebook is in the data sets. So based on the latitude, longitude, looking at the whole water body area, we can be able to see some of the extents from 2019 to 2024, giving you quite some useful insights. So you can get the insights based on the turbidity index. And these are quite informative. And we'll be having the whole service active for the whole context just in a few months from now. This will actually be useful to complement your work, your research, and your contribution to the community. Service, we're able to change the background. Continental services, we have the coastal, the coastlines. You can be able to go to the coast from Tokaradi, or to Cape Coast. We can see the extent of our coastline from the year 2000 to 2024. We can also see the various lagoons, Econ, and you can be able to see hotspot areas, the red, the blue are relative okay. looking even at the port and seeing the trends, the coastline. You can do the measurement just to see from the change of the coastline. Some of them could be over 30 meters or plus. Looking and going to further Auna Beach, Cape Coast, Accra, look at the various lagoons. Look at the various harbors, Tema, all through. You can see quite some developments in the lagoons, especially this area of Adwa, where the water meets the ocean. You could also add additional data sets like on the water observation for space, get buoy sites, the Volta meets Atlantic, uh, looking at also Keta Lagoon. So this is quite informative. So the coastline covers 38 countries, and you can see generally from space how things look as an outlook. So from that now, are we able to look at individual cases like coastal erosion around Fevume village? You can be able to get the change in the coastline over time. Also looking at country level coastal scale coastal change. So this is in the use case folder, and here we specify our country, Ghana. We're able to see a lot, selecting our country, Ghana, looking at the rate of change. This notebook typically would take like 3 minutes to run. So it's able to run and give us an overall change and specify our total of coastline, 643 kilometers. And of these, some of it has experienced a lot of change over time. And some of these has retreated or gained, or some of it has been without significant change. Then we can inspect using our shapefile for the administration. Looking at the different regions we have, we can summarize our analysis country level, very useful to make a decision. Looking at the Greater Accra, Volta, Central and Western region. And as we move further now, we can see the specific areas affected by coastal erosion. These are Greater Accra, Central, Volta, and Western region. And combining these with data on the population to estimate population exposure. We're able to see the rate of the shoreline affected and how much change has occurred over time, and the population of people vulnerable over 1 million. And now looking at specific points, we can just zoom in to specific areas or specific villages, especially around the lagoon, protected areas, especially Ado, Foma, Keta Lagoon, small area around Kenzi, Kedzi. This is a legend above. Some deep purple there. Some of the areas affected. Also around Densu. Also going around looking for specific hotspot areas also observed around the Koradi. So this is quite useful to give us some assessments that we could work further to refine. So all this work is also dependent on your support. Looking at the dashboard, the whole, looking at our country, Ghana. So looking at the example of floating marine debris, and also looking at cross-cutting examples and cover. Looking also at land degradation, we have a course module on land degradation, and land degradation, we able to generate and use land change detection, vegetation change, and also Youth Africa is very grateful for the support from the youth purpose and the Africa Women in GIS, especially through the technical challenges that we've held and having winners from across the continent. Please, we'll be happy to have you in the Insights page, and where we could showcase some of your work, where you could submit some of your work and we showcase it. We have the learning platform, which is self-paced, and in the learning platform, we have the courses in English and French, and the course on the introduction to the platform is something we'll be encouraged to pursue and maybe share your success, showing us your certificate. So when you explore the courses, you'll see, discover new and see all the courses that we have, Dear Africa, Introduction to Sandbox, and other courses, the water bodies, and our partner courses. And from this, we can be able to look at the introduction to the Africa platform. And here you'll see the course itself. You can view more information. You can also look at the course staff, myself and Edward Boma. We could also connect with us as well. And when you view the courses, you can be able to get more information, especially the sessions. And from these, you'd get a certificate of completion, which you could share with us or share on the social media and give yourself some visibility. So you can monitor the progress of the course. Here you can qualify a certification where you get 90% and above. And also we have the other courses as well from ourselves and our partners, and you get a certificate of completion. So the courses in water applications are from IMI DIWASA program, very insightful course also on coastlines, etc., etc. So some of the interesting modules. This is the best platform. Also, back you can see the user guide giving you more information about the resources, the access to the platform, including the API, the sandbox, the courses, as well as the API, including also the job portal, the sandbox, and other platforms, accessing the platform through the API, the ODC stack, as well as the web services. Our platform is free and open to all, and please connect with us. We also have the lively sessions. You can join us every week, Wednesday, 11 a.m. GMT0. Also, Africa Job Portal. You can access more resources. Our partner, Esri, and also we developed courses with Esri, how to access our imagery on the Africa Job Portal. Also, we have the YouTube Africa YouTube channel where you can get more information on the recordings of these live sessions. You can look at the playlist so you can see live sessions in English and French. So at least it gives you an idea of the platform, how it is easy to access, and also welcoming you to join our live sessions in English and French. And the Africa acknowledges their partners, helps the trust and Australian government, and thanking you for joining us and helping us to unlock the promise of tomorrow together with you. Thank you so much for joining us today. Thank you. Madasi.